The most important thing when you are drawing a scatter plot is when you're setting up your axes to make sure that you get your axes correct, which is your independent and which is your dependent variable. Otherwise, you could be spending a lot of time fixing mistakes if you switch those axes in the wrong place. So first of all, we have to ask ourselves, we want our independent variable is going to be our x-axis. What's this thing oftentimes is the thing that affects this one up here, the dependent. This variable here is dependent on what happens to this one down here. So in this case here, we have a flight in the distance in miles, and we have the time from the gate in minutes. And in this case here, the distance actually, the time that it takes for the flight to be is very much affected by how far that flight is. So this one's going to be my y-axis up here, and the time is, I'm sorry, I take that back. The flight is going to be, the distance is going to be my independent variable, and that is going to affect the time it takes for that flight to be, which is going to be my dependent variable here. Now, once I've decided on that, I need to find my scale. When I look at my flight distance in miles, I'm going to look up at these things here. What's the biggest one here? Looks like 480. I need this to go up to 500. In here, if I did, let's see, 100, 200, 300, 400, not quite. Okay, so I'm going to have to make each one of these maybe 100 or 150 in order to fit those in there. Maybe 150, or sorry, yeah, 150 every two, or 100 every one is going to be what I choose for my scale. And then for my minutes, it looks like around 90 minutes is my biggest one. Again, if I go 10, 20, 30, 40, 50, 60, that's not going to make it to 90. So if I go by 20s, 20, 40, 60, 80, 100, that is going to work. Then I need to go ahead and plot my points here. So if I look at my first point, it's a flight distance of 240 miles and a time of 56 minutes. So I go to about 240 and about 56 is about here. Find where those two go together, and then I'm going to put a dot right there. Once I plot all of those points, then I'm going to take a ruler out and connect the dots as I best can. Okay, in there. And when I do that, basically, eventually I'm going to be coming up with an equation for this. And in my equation, I just basically need a slope and a y-intercept to put it in slope-intercept form. So I'm going to find 2 points in here. I'll take one here, and I'll take another one here. And what are those points? Those are the points, looks like the first one is around 0 and something a little bit less than 20. So looks like it could be around 15, 16. I'm going to say it's 16 in there. And then the other point here that I have over on the far right of the curve is 500 and maybe around 95. So I've just chosen 2 points on my line. Notice that I'm ignoring all the points that are the green points here. All I care about is 2 points that are on my line. I choose 2 points as far away as possible from each other to help me make this a little bit more accurate, okay? And that's going to help me to do that, so I've now moved on to the next part. Okay, so to come up with an equation for this line, all I need is the slope and the y-intercept to be able to put it into slope-intercept form. I can find the slope by finding the slope between these 2 points, and I can find the y-intercept because one of the points that I chose is 16 is actually my y-intercept. So in fact, right now, I know that I have y equals to mx plus 16. The only thing left for me to find is the slope. So I'm going to go ahead and find that slope right now. I do the change in the y's, which is 95 minus 16, over the change in the x, which is 500 minus 0. And now I can go ahead and reduce this fraction down. So I went ahead and reduced that. It's 95 minus 16, I got 79. 500 minus 0, I got 500. And I could write my equation right in just like that, where I have y is equal to 79/500, write it as a fraction, times x. Don't forget the x there. The x is always going to be in that equation like there, plus 16. So there, I could be done right there. There is my equation in slope-intercept form. I could also choose to write it in decimal form, my slope, and I get y equals 0.158x plus 16, like that. Either way, the slope is the number, the coefficient of the x term, and the y-intercept is the constant term, the one that does not have the x in it. Okay, now I'm going to use this equation to predict how long it would take an airplane to get from one gate to the other if it had to fly 1,200 miles. Well, the miles that we fly is x, so I need to plug in the 1,200 in for x into this equation and then find y. That's all I have to do. So I plugged in the 1,200 in for x, and then I just simplified it down, multiplied the 1,200 times the 0.158, added 16, and I got 205.6, and I just rounded that to 206 minutes. So how long would it take to fly the 1,200 miles? I would guess it would be approximately 206 minutes. All right, now that was plugging something in for x. The next part here is actually looking at the same equation in here, but this time they're giving me the time, which is the y, 5 hours. Now, my time is in minutes, and so I need to multiply 5 times 60 to get 300 minutes. That's an important part in here. All right, and so that's the first part here that I'm going to do. So I took my equation, y equals 0.0158x plus 16. I substituted in 300 in for y, because that's how many minutes is 5 hours in for y, and y is my time. And then I solve for x. So how do I get x by itself? X is being multiplied by this and added by this, so I subtract the 16 from both sides, and then I divide by the 0.158 from both sides, and I end up with 1,797 point something, or about 1,800 miles is about how far we'd expect to go if it was a 5-hour trip. Okay, so what's the slope of my equation? I could use the 0.158 and use that number there, or I could go back and look at the previous page in here, and we also, oops, sorry, it's actually above here. We could also use the 79/500 as my slope. Either one of those is the slope. And what does it mean? Let's talk about that in terms of the fraction and the decimal. So if we go back to when I calculated the 79/500, the 79 was me subtracting the two different various minutes from the vertical. The vertical measurement was minutes, and this was my horizontal change, which was the difference in miles. So this is what I found is my slope is I'm going to be able to flying 79 minutes per every 500 miles, or if I make it as a unit rate, that means I'm going to be 0.158 minutes per mile. Again, minutes per mile is the same units here, but this is minutes per 1 mile, okay? So that's what that number tells us. That's how many minutes it's going to take for us to do each mile. What is the y-intercept here? The y-intercept was 16, so we can write that in there. In this real situation, what does that number mean in terms of minutes and miles? That is actually 16 minutes, because remember it's y equals, and what does it stand for? What is that extra 16 minutes that we're adding on there? And that is the 16 minutes on the runway. All right, and so that answers the questions we've been looking for.